C.
Okay.
So, like, as you know, the area of a circle is pi r squared. So when we're working out the area of a sector, we're just multiplying it by x over 360. So
Yeah.
for question A, to work out the area of that, the full circle would look something like this. So it's good to visualize that. So that would be pi times by 7 squared, and then times by 25 over 360. So that's 49 pi times 25 over 360. And what do you get when you put that in your calculator?
I got 245 over 72 pi.
Okay, that's fine. And then depending on the question, you can keep it as in terms of pi or as a number. That's fine.
Okay.
Cool. Let me know when you're done with B and C. So because they're weird numbers, I'm just going to put them as the question in the exam will always specify. But for this one, I'm just going to round it to three significant figures. So 10.7 centimeters squared. Um, the next one, pi times 50 squared, and then times by 70 over 360. So that would be 1527.16. And then what do you get for the last one?
The last one I got. Wait, do you want it to three significant figures?
Yeah,
I got 447.
good. Well done. Cool. Now, this is where what I wanted to get into mainly. The question to work out the area of a sector these days is too easy for you guys. You're too smart for that. So they're going to ask you to work backwards. And this is where you can probably get it, but having the right method and being consistent is very, very important. So I'm going to do part A in my way, and then you can do part B and C following like a very nice method. So
Okay.
if we look at this question in particular, we've got pi r squared times x over 360 equals the area. I've not done anything, I've just written the formula. Now I'm
Yeah.
going to put substitute numbers where I know that where I know the value, right? So pi, the radius is x, so I'll keep it as x squared times 115 over 360 is equal to 20. Now, how do I carefully rearrange this? Well, there's a couple of ways. The nicest way is to go bit by bit. We don't like fractions in math, so I'm going to move the 360 over. What would you do to move the 360 over?
Times the other side by 360.
Good. So 360 times 20 is the same as 360 times 2 with an extra zero, so 7,200. Now we've got 115 pi squared. I should have just written that 115 pi x squared equals 7,200. How would I get x squared by itself?
Divide 7,200 by 115 pi.
Good. And then finally, x equals the square root of the answer. I don't need to show that. And then x is equal to square root of
I
90
got,
something, which is 4.46
yeah,
centimeters. Okay. So that's like the a little bit longed out, but that's the best way to do it with these types of questions. You saw in your own mock that it came up, and you just want to go step by
yeah.
step. So try B and C, but don't rush it at all. Make sure you're fully confident with each bit of the rearranging. So with part B, we're just going to substitute the value. So so we're going to put pi x squared times 26 over 360 is equal to 98. Can you just tell me how you would rearrange that?
Uh, Multiply both sides by 360. So
Perfect.
you get like pi x squared times 26 equals 98 times 360.
And I'm just going to adapt it slightly. I'm going to write 26 pi x squared. It's just a bit tidier. Is equal
Yeah.
to 98 times 360. And that is 35280. And then the next step,
Uh, After that, oh, divide 35280 by 26 pi,
Yeah, good. Divide both sides by 26 pi.
and then you just square root that.
Good. And then what did you get?
I got 20.78.
Good, that's correct. 20 point, let's just say 20.8 centimeters. Good. Well done. And then the last one, we're going to substitute the values. We get pi x squared times 252 over 360 is equal to 1. Um, so multiply both sides by 360 and tidy up the left-hand side. So 252 pi x squared equals 360. And do you see what we're doing with the 252? We're just writing it a bit tidier because
Yeah,
as we get further into maths, things get messy. So it's good to form those habits of number at the front. Um, and then just divide both sides by 252 pi. And we get a weird number. We get x squared equals 0 0.4547 something. And then x equals square root answer. And it doesn't specify to change it to meters or centimeters, so there's no need. So we just get an answer of 0 0.674 meters.
yeah,
Okay, perfect. Same thing again. We won't do every single one of them, but let's do one question. I'll do the first one, then you can do the next one, and then we'll move on.
yeah.
So for the angle, again, it's the same thing. Because it's talking about a sector and the provided information was the area, we're using that formula straight away. So remember, there's like this subtopic in maths, which is not something that you're exactly taught, just forming equations. So whenever they give you a piece of information, you're straight away thinking, what equation can I form? So area equals pi r squared times x over 360 is my equation. Substitute the values. Area would be 17.45 is equal to pi times 5 squared times x over 360. Now, this is coming back to your basics. How can we tidy this up and write it in a pleasant way?
Uh, do like,
Actually, there's so many different ways. So, um, I'm thinking, let's do the same thing we did in the previous question. What was the next step?
uh, did you times by 360 first?
Yeah, let's multiply both sides by 360. So 17.45 times 360, 6282 is equal to pi times 5 squared times x. What's a tidy way of writing that? Pi times 5 squared times x.
5 squared pi x,
So what is 5 squared?
25.
Good. So if it's something small you can do in your head, that would always help. So 25 pi x. See, that's
Yeah,
much tidier, right?
yeah.
Good. And the final step?
Divide by 25 pi.
Good. And we get an answer of 79.98, which is 80 degrees. And you can always have a rough idea if you're completely wrong or kind of right. There's no way of telling for sure unless you substitute back in, but you can look at the shape and see that it's around the 90-degree mark.
Yeah.
Okay. Um, could you please try B and then let's see how confident you feel. Then we can maybe do C.
Okay.
So the area is 62. So substitute that in. 62 equals pi times 8.5 squared times x over 360. What do we do next?
Multiply by 360.
Good. and then tidy up the left-hand side. Well, 8.5 squared in my calculator is 72.25. So I can just write 72.25 pi x. And then what would be the final step to get the answer?
Uh, Divide by 72.25.
Good. So only 72.25 pi, right?
Sorry, excuse me.
Divide by 72.25 pi.
Yeah. Oh, sorry, did I forget to write? I
You
forget to
forgot
say
to say
pi.
pi, but if you did, then that's fine. So what was your 98.3 is correct anyway. You got it right.
Okay, cool.
Yeah. Cool. We'll leave part C and we'll move on to the next question. This one's
Yeah,
very easy, so I'm just going to speed really quickly through it. The formula to work out the circumference is pi d. Yeah.
yeah.
So the formula for the arc length has to be. Wait, what do you tend to prefer? 2 pi r or pi d?
Uh, I think 2 pi r.
Okay, let's go with whatever you prefer. You can use either, it won't affect the method at all. So if
Yeah,
the so then arc length L is always going to be equal to 2 pi r times pi, our favorite, x over 360. Yeah,
yeah,
cool. So for this one, L is going to be 2 times pi times 6 times 90 over 360. That can be chucked straight into the calculator. It's just 12 times 90 over 360, which is 3 pi. And if you want to work out with the pi, you can, or you can leave it at that. Okay. This should only take a minute, so just speed through all of them. If it's a nice number, leave it in terms of pi. If it's a weird number, do the decimal.
okay.
Did you get the 10 pi and the 2/3 pi?
Yeah,
Good. And then the last one's just 2 times pi times 20 times 72 over 360, which is 8 pi.
yeah.
Good. Um, cool. So then again, it gets harder. Why? Because they ask you to move backwards rather than forwards. So it's the same principle. We want to write out the formula. L
Okay.
equals 2 pi r. Oh wait, no, this is oh wait, sorry, this is one extra thing I forgot before we work backwards. This is the perimeter. So we're just gonna do one of them. We're gonna work out so what does perimeter mean?
It's like the length of the like outline, I guess.
Yeah, all of the length, all of the sides added up. So we know
Yeah,
that this is 6 and we know that this is 6. So we only need to work out L, which is our arc. And we already know that L is going to be 2 pi r times x over 360, which is 2 times pi times 6 times 60 over 360, which is equal to 2 pi. Okay. Um, so that's the arc length. How do I get the perimeter from that?
You just add 6 and 6.
Good.
Just add
So
12.
good. So perimeter equals, and little things like this. Notice how I put L here and perimeter here. So I'm putting clear titles of what I'm working out. So perimeter
Yeah,
equals 2 pi plus 6 plus 6. Then you can work out the answer as 2 pi plus 12, or you could do it as a decimal. But that's
okay.
so even if we had to work out the perimeter for all of these, in the first case, you're just adding on 12. Second case, you're adding on 15. Then you're adding on, sorry, 15 plus 15. Then C, you're adding on 4 and 4. And then D, you're adding on 20 and 20. Does that make sense?
Yeah,
Cool. Okay, let's move on to this where we're actually working backwards. So we've got the arc length and we need to work out the length of the radius. So L equals 2 pi r times x over 360. First step, substitute the values. I'm going to actually let you try first because you have the idea from the other question.
yeah,
So for this one, the arc length is 50.
yep,
In other exam questions, they may even show the perimeter. So just subtract like, then it becomes quite hard. So in this case, 50 is equal to 2 pi. The radius is x in our question times 20 over 360. There's so many different ways to deal with this. We've been going down the route of multiplying by 360. But you can also
Yeah.
simplify the fraction and move stuff over to the front. But since we've been doing that, let's times both sides by 360. So 18,000 is equal to, and then what would the right side tidy up to if you got 2 pi x times 20?
Uh, 40 pi x.
Good, well done. Um, and just to double check, you understand why we don't need to times this by 360, right?
Yeah.
Because this is all one term, right? And yeah, does that make sense?
Yeah.
Okay,
Yeah, I get that.
cool. And then just divide both sides by 40 pi. So x is equal to 18,000 divided by 40 pi, which gives us, what did you get?
I got 143.24.
Good. Well done. Cool. Do B and then we'll stop there and we'll do the last question before we move on.
Okay.
So we've just done the same steps and multiplied by 360. What's the final step going to be?
Uh, Divide by 70 pi.
Good. So that's 139 centimeters, and then we're good. Okay,
Yeah.
let's move on. Last question, then we're done. Um, the only thing harder than all of this is if they bring the perimeter in and ask you to work backwards. We can maybe try that as a challenge, but uh, just talk me through part A without us doing it before. How would you do part A? What formula would I use?
So it'd be x over 360 times 2 pi r,
Good. And then what would I
and then
substitute in?
we do 2 pi r times, wait, no, 2 times pi times 27 over times x over 360.
Good. How would I tidy this up?
Uh, 52 pi
Good. And then our
times
usual multiply by,
360.
good. Let's do that first, just so there's no fraction. So we get 2160 equals, and then you're already saying that 54 pi x, right?
Yeah,
And then finally, what's the answer? X equals. What do you do?
over
Oh yeah,
54 pi.
good. And we get 118.8. Yeah. And that's the angle. And that looks quite right because this is 90 degrees and we're just a bit above it. Yeah.
Yeah.
Cool. So we won't do B and C, but that's perfect. We done it step by step. Little things help a lot, like the multiplying by 360 and knowing what order to rearrange in and taking your time substituting. So that's really good.